Alright, this is going to be a quick one. This is showing Wyvern, the beta 2 build that I uploaded the other night. Fixed a few things, primarily the bladeRF, kind of removed Crocodile Hunter for now until I figure out how to get it to compile with Arch64. Uh, but what we're going to show is just another usage of Wyvern to control radios remotely. Um, Wyvern wasn't really meant as a whole nother Dragon OS with a desktop environment. It's really just headless, and the goal was to try to make a platform that can send information back to the main instance of Dragon OS. Hopefully that makes sense. So I'm over here running live on a laptop here at Dragon OS. I'm going to SSH with the default username, and I just know that that's its IP address, and the default password is Dragon. So make sure you change that. And I'll pull up another terminal too. I guess I could push the other one to the background with screen, but this will just demonstrate a little more of how you can set this up. And what we're going to do is just take a look at GRGSM, um, the headless, I think it's called. Is that what it is? Yeah, headless. So in one window, just like I've shown before, you would do GRGSM scanner. You can take a look at some of the settings here, or some of the arguments or options. And we'd want to do, in this case, a -B for band, and then whatever band was available. Um, in this case, I have a bladeRF plugged in, so I'm just going to specify bladeRF, and that's really about it. Um, I have to actually hold the radio up, so if I run this, and you can do a -V and a -D to see more. Matter of fact, okay, so we already got results there. So you'd want to take the information that you got back, primarily the frequency, and we'll remember 1930.4, clear that out. We'd want to run GRGSM LiveMon headless, and again, let's take a look at some of the options. And we'd just do the --args for the bladeRF. We do the -F 1930.4M for megahertz, and leave pretty much everything else default. And we'll start that up. That'll use the bladeRF, and again, I'll probably have to kind of hold the radio up. So if you're getting information like this, you know you've got it set up right. I'm going to set it back down a second. So now if you open up another window and you browse to the user source in Wyvern on the Raspberry Pi, you have a look around, you're going to see some of the programs that I've installed and the source that I've left behind as needed. And if we go into our IMSI catcher, we're going to see we have some files there. And all we really need to do is run sudo python 3 simple IMSI catcher --sniff. And if you run that command and you're getting data in the top window scrolling past like this, you will get results. So that's one way of running GRGSM remotely without a desktop, but just a headless environment. And so that's just one thing that you can do. You'll notice I've left behind. I was going to start taking a look at mod mode map, which is another survey tool that can use the GRGSM engine or the SRS LTE engine. I started taking a look at Iridium. I think that that's possible to run all remotely, although it did give a notice about using Python 3 is about 15%, I think it said, slower than the normal Python 2, so I need to take a look at that. And then if I get a chance, I was really trying to dive in and figure out this SDR Angel, well, really a Docker that you can add and run it headless and remotely, and so still need to figure that out. And then also, last but not least here, if we take a look at the LMSTCP again, I'm trying to plug this limesdr in, we'll notice that, so let's just try, for example, we'll run LMSTCP and look at the options here. So what I did was modified the source so it would appear it's an E4000, I think it's called, which I don't own. Let's see, and we want to, let's see, collapse this. We'll do a listen address and a antenna auto, and that's all I'll change for right now. So alright, so we'll run LMSTCP like this, and I'll open up we'll just start with fresh settings on the live main laptop here. And just like I showed before, we'll go down, we'll do the Spectrum server, and we'll change from localhost to the IP of the Pi. We should be able to take the input rate and the bandwidth. We could probably raise to, but I'll just show the connection is made here. And so now we can take it up to 2.2 gigahertz using the limesdr. And of course I don't have an antenna on it for this range, but just to show you what's possible with the limesdr as a remote sensor here. So, but alright, so there you go. There's a couple things that you can do with Wyvern running on the Raspberry Pi back here and connected with Dragon OS.